Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, now it's been more than 3+ years I've been uploading videos that are related to data science, and I've always made sure that I've covered each and everything, let it be with respect to machine learning, deep learning, neural networks, NLP based problem statements. I've also implemented a lot of end-to-end projects with deployments. A lot of knowledge sharing has been there, and I've always focused on the basics first of all, right? Now, utilizing this basics. Now, if you're probably following my channels for a longer period of time, if you have seen my videos where I've written everything, mathematical concepts, how it is related to a specific problem statement, all those things has basically been covered in my YouTube channel. Now it's time that we start learning about more advanced things. In this video, I'm going to talk about like how ChatGPT is trained. And if you probably see this entire information, what I'm going to talk about in this particular video, you will be seeing that most of the things I've already covered, right, in my channel itself, right? And then that is probably added in a cumulative way. It has been combined together, and then probably ChatGPT is trained, which we are currently using it, right? So a lot of amazing things that is going to come up, because as I've already told and I've posted in my LinkedIn that I'll be talking more about generative AI, LLM, that is large language models, and if I talk about ChatGPT, it is also a large language models. Okay, now first of all, let me just go ahead and give a brief definition about large language models, and then we will try to understand about like how ChatGPT is trained. There are a lot of things that are going to come up probably in this specific playlist. The playlist information will be given in this particular description of this particular video, where I'm just going to focus more on generative AI. What I feel is that in this upcoming days, in upcoming years, right, couple of years, a lot of startups that are going to come up, they may be working in this generative AI because there are a lot of work to be done. Amazing use cases can be solved through it. And I can see that many companies are there who are currently working in this. Now, first of all, let me just give you a small definition about a large language model. Large language model, right? They are very big models altogether, and they have been trained with huge amount of data for solving some specific problem statements. Now, it can be a kind of text-to-text model, which can probably be used as a chatbot for conversation and all. It can also be like a text-to-image model, where you're just specifically giving a text and it is generating its own images. Similarly, text-to-video, text-to-audio, this kind of models are there. And when I say, just as an example with respect to ChatGPT 3.5, it has been trained with 175 billion parameters. It is basically having 175 billion parameters. Just imagine how much data has been trained with, right? And currently, I've already explained in my previous video, like ChatGPT, whenever I talk about this has been trained with internet data, right? Different kind of data, all available in the internet. It has been used and it has been trained, right? And it obviously has huge amount of parameters, whereas in ChatGPT 4, it has more billion parameters when compared to ChatGPT 3.5. So this was the basic definition about LLM models. I'll be talking more about it as we go ahead. But in this video, let's focus on like how ChatGPT is trained, which is super important. And I'll just share my screen over here. So here I have actually created all these diagrams to just make you understand. But just to understand how ChatGPT was trained, I have explored a lot of research papers from a past month, a lot of different resources, materials that are available in the internet about ChatGPT, blogs. Even I have explored the ChatGPT website, the research paper that was basically generated for this, everything I explored. And I found out multiple things to probably explain about this. I'll try to break this down. But before I go ahead, there is an amazing article written by Pradeep Menon. You should definitely check out this. I will be providing you the link in the description of this particular video. And it looks completely amazing. He has explained in an amazing way. And this last two diagrams that you will be seeing over here, right? If you probably explore this last two diagrams I have also copied and pasted. So definitely a lot of credit goes to this specific article, which is written by Pradeep. So I will just try to explain you again, but not if you probably read this, you may get some amount of understanding, but currently what I will do is that I'll give a lot of examples over here, right? So that you will be able to relate it, like how ChatGPT is trained. Now, to start with, ChatGPT entire model is basically trained in 3 stages. Okay, the first stage we basically say it as generative pre-training. Okay, and before you probably really want to understand about ChatGPT, you should also check out my video in YouTube regarding transformers, okay? Because this is the base. So if you search for Krish Nayak transformers, right? So here you will be seeing that I have created a live session over here. This specific video you should definitely refer to, because this is the video that I probably uploaded 2 years back. And if I talk about models like ChatGPT or Bard, you know, they are specifically using transformers architecture, which has an encoder and decoder. Okay, so definitely check out this particular video if you really want to know about transformers. Okay, so in the stage 1, you probably train a generative pre-training model, through which you get a base GPT model. Then in the stage 2, you do supervised fine tuning. I will be talking about each and everything of this, like how this generative pre-training is basically happening, supervised fine tuning is happening. And then finally in the stage 3, you basically do the reinforcement learning by using the human inputs, right? So that kind of not human input, but I'll just say human feedback, right? So that is the reason it is written as reinforcement learning, human feedback. And finally, you get a ChatGPT model. Now, this first step that you probably see, the stage 1, right? Generative pre-training. What kind of data is basically required from the entire internet data, right? It can be website, articles, books, public forums, a website which is probably having tutorials, lot of things, right? So those all internet data is basically taken to train the ChatGPT. So let's go ahead and deep dive and talk about this, okay? But let me just give you a basic example, like what a LLM model looks like. Let's say that I am a person over here, and I am really much interested to know about dogs. Okay, so what I did is that I have explored 5-6 different types of this big, huge 500 pages of books regarding dogs, and I have probably read it about it, and so I know many things about the dog. Now you can ask me any questions, so I will try to answer any new thing about that specific dog. That is only present in the book. Okay, that is only present in the book. So this gives a brief idea about a LLM model, where you are able to answer something after probably getting trained or reading it from multiple books. Okay, so this is just an example. But when we talk about the stage 1 generative pre-training model, so what exactly is basically happening over here? So first of all, let me make this as a full screen. Here you have an internet huge input data. Okay, so here you basically have an internet huge input text data. You pass this data to the transformers. Okay, transformers, when you pass this huge amount of data to the transformers, in transformers you have encoder, decoder. I've explained about transformers a lot in my live session. Please do make sure that you watch that particular video. After this particular data, this huge data is basically trained with the transformers. It basically creates a base GPT model. Now, as you know, what all tasks a transformer will be able to do it. Transformer can, they are able to do this kind of tasks like language translation, text summarization, text completion, sentiment analysis. So this is the kind of task that transformers can easily do. And just by training this huge amount of data, we are able to get this kind of task and we are able to solve these problems, right? Even in transformers, there's a concept called as attention is all you need, right? And based on that, all these tasks can be easily implemented. And I've also shown a practical implementation with respect to that particular live session also, right? Just in Google Colab notebook, right? If you have good amount of data, you will also be able to implement this. Okay, so once this task is implemented, but our main aim is basically to use this ChatGPT model for conversation, right? What we want basically a conversation chatbot, right? So we want this functionality where we are giving a request and the chatbot is giving the response. That is the functionality we want. We don't want this independent functionality. This functionality can be combined in the response part, right? So in short, when we probably create a generative pre-training model, what we are specifically doing over here is that we are able to get this sub-task kind of task over here, right? All this language translation, text summarization and all. Now we need to convert this task in the form of request and response, right? So that is the reason why 3 tasks are basically required, right? So now what we do is that we go to the next step, that is next stage, supervised fine tuning. Now what exactly this supervised fine tuning is with respect to SFT? It is also called as SFT. Now in SFT, what happens is that in one side, a human being will be there. Okay, let's say this is a human being over here. Let's say I'm sitting over here. right? And I'll talk about a very important role nowadays, which is very much famous, which is called as prompt engineering role. Okay, we'll also talk about that. Okay, so here on the left hand side, one human will be there. On the right hand side, another human will be there. And this human will be acting like a chatbot agent. Okay, so what happens is that whenever this human being sends a request, let's say it asks a question like, hello, how are you? So the another human will say that, yeah, I'm very good, I'm fine. Okay, some response will be there. Then again, this human will send another request. Then again, the another human will probably send the response. So like this, it will be having the request and response continuously. So these are some real conversations, and these all conversations will be getting captured. So guys, now this kind of real conversation will be converted into an SFT training data corpus, right? Now this SFT training data corpus will basically be in the form of request and response. Request will be your input and response will be your output. Okay, so like this, lot of requests, lot of different responses. It can be right for a similar kind of request. There can be multiple responses also. So they will try to first of all create this kind of training data corpus, and it will just not be one or two records, but millions of records, right? Millions of records. Now, once this is basically getting created, you can see request is conversation history and response is the best ideal response itself, right? So this format of training data corpus will basically get created, and then it will then be sent to the base GPT model, right, for the training purpose. Now, once it is sent to the base GPT model for the training purpose, then over here the optimizers, according to the research paper that is basically being used, the optimizers that is used over here is called as stochastic gradient descent, right? And from this, you are basically getting an SFT chatbot model. What is SFT? SFT I have already written over here. It is a supervised fine-tuning model with respect to ChatGPT. Right? So SFT ChatGPT model I will be able to get after I probably do the stage 2 or supervised fine tuning. Now, still there are a lot of problems with this. Obviously, it will be able to give you the answers, right? But this model, this SFT ChatGPT model will be able to give you the output based on the data it is basically trained with. If I probably ask some other questions to this particular ChatGPT model that may not be there in this particular training data, then it will start giving you some awkward answers which you may have not been seen also, right? So this ChatGPT will start behaving in a way you'll also not know what exactly it is trying to say. And this all problems was faced also by the researchers when they were actually creating this. And that is the reason they came up with the stage 3, which is called as reinforcement learning through human feedback. Now, because of this step, the model that was now created was called as ChatGPT model. And right now, whatever things you're using with respect to ChatGPT 3.5 or 4 is basically using this reinforcement learning through this human feedback. Now, let's understand what exactly is happening over here. And here, I'm also going to give you a lot of amazing examples to just make you understand, because the most complex thing is not this. See, data creation is always a task that we probably do as a data scientist. This is also not a very difficult step, because there are transformers. We are using the same architecture. We are just taking huge amount of data and we are training with it, right? The most important step is this. Because of this, the accuracy of the ChatGPT has been increased in a tremendous way. Right now, what exactly is this reinforcement learning through human feedback? So over here, when we have this SFT trained model, let's say a human agent gives a request, then SFT ChatGPT will give some kind of response. Now, similarly, for this kind of request, we may have multiple response also, right? We may have different response. Now, this is based on this particular response over here. You can see these are all my alternative response. Now, when I say through human feedback, where this new human has been put up over here in this, right? So once we probably get multiple different responses, now this human agent, what it will do is that it will try to rank all this response, saying that which is the most suitable response, right? which is the most suitable response or which is the best response. Based on that, ranking will get assigned. So here you can see response B is the best, then response A is the best, then response D is the best, then response C is the best. We are ranking all the responses. Now, based on this responses ranking, what we do is that we create a reward model. Basically, the researcher created a reward model wherein based on every response, they probably provide a score, right? For every response, they provide a score, and this score will be based on probability. So it becomes a binary classification. If the probability is high, right? If the probability is very, very high, probability ranges between 0 to 1. If the probability is high, that basically means that particular response is a very good response. If the probability is low, that basically means that's for that particular response, the score is less, right? Now this reward model. Now obviously if I'm explaining you like this, it is very difficult to understand. So let me give you an example over here. Let's say that there is a chef, okay? Now this chef knows how to cook any kind of food, okay? Any kind of food. Now suddenly in a restaurant, there is a request saying that from a customer, hey, I want to have a very good non-vegetarian food. Okay, it can be chicken, right? Something. I'm just giving some things, right? Like chicken, right? And I want to have it on dinner, right? Now, if probably the chef gets this kind of request, chef will not initially know like what food should I create. It depends, right? If the chef is from India or he's from some other foreign countries, they'll try to create that kind of things that is actually likable by the chef, right? So what chef will do now? It will first of all ask from many people, like what kind of food would you like? So this is the initial response that is taken. So these are all my response that is basically coming up, right? So these are all my response. You will be able to see that I'm picking it up, right? So chef initially will put up all the responses, right? And it will also ask that, okay, fine. Then what will happen based on this responses, it will try to rank it, right? How many people have told that similar kind of responses, right? If many people have told, okay, I like this specific food, obviously it can try to rank it, right? This can be greater than this can be greater than this can be greater than this can be less than this. Now, once we try to rank this specific response, now chef, what it will do is that it will try to create a reward model. And this reward model will be very, very simple. It will be a binary classification. Over here, cross entropy is also used, okay? Cross entropy is used. Now, based on this, what happens is that whenever the chef gives any response, right, it should be able to consider that whether we should go ahead with this particular output or not, or whether should I cook this particular food or not, like that, right? So, this is what is the reward model that is basically getting created. And this is based on the feedbacks. The feedback is probably coming from the human beings over here, right? So I hope you got this specific idea about it. Now, once a reward model is basically created, then reinforcement is basically applied by a technique which is called as proximal policy optimization. Now, based on this proximal policy optimization, all the things that is basically happening is that reward model, first of all, updates the reward based on the response that is probably coming from the ChatGPT model, right? And then it will also make sure that it will update the specific rewards by using this proximal policy optimization technique. Again, in this technique, if I probably I'll not explain about proximal policy optimization right now, but I'll make a dedicated video about this. But again, understand that this is a reinforcement technique wherein we will be able to improve the ChatGPT response, and based on that, whatever human feedback or response is coming up, it will try to make sure that it will try to increase the reward if the response is properly correct. Right? So that is the thing that is basically happening over here. And finally, we basically get a ChatGPT model, and this reward updation and the policy model that is probably getting updated using the proximal policy optimization will happen continuously as the conversation is basically happening, right? And this is how the entire process of reinforcement learning happens through human feedback. See guys, I know from this, whatever things you know, you are very much familiar with stage 1 and stage 2. You may also know that how you can probably create this particular data set, right? That can be a manual approach, but yes, you can definitely do it, right? Only the most complex thing that usually happens is over here. But understand, if you are able to understand things, right? Writing a code for this is also very, very easy, probably you can do it. But it will not just be possible by any companies to do this, because they definitely require a huge amount of data set, right? So this was just an example to show you that how ChatGPT is trained. I would definitely like to talk about this particular article, which has been written by Pradeep Menon. I will be giving you the link regarding this. You will be able to understand, just read, just go through this, just try to understand what all things is possible over here. And then just let me know whether you're able to understand or not. But going forward, I'm going to discuss about generative AI, LLM models and all, where we'll try to break down like how I broke down this by providing a lot of examples. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Have a great day. Thank you, one all. Bye-bye. Take care.